may have relaxed in a natural hot springs pool, or seen the old faithful geyser blasting hot water into the air in Yellowstone National Park. But have you ever thought of where all that heat comes from? Well, it comes from deep beneath the surface of the Earth, and it's called geothermal energy. And we can use it to generate clean, renewable electricity. Okay, here's how geothermal works. Heat from the Earth's crust warms water that has seeped into underground reservoirs. In some places, when water becomes hot enough, it can break through the Earth's surface as steam or hot water. This usually happens where the Earth's crust, or plates, meet and shift. In the past, taking advantage of geothermal energy was limited to areas where hot water flowed near the surface. But as geothermal technologies advance, we can leverage even more of these natural, renewable energy sources. The environmental benefits of this clean, round-the-clock, renewable energy source are substantial. Low emissions, small physical footprint, and minimal environmental impact. The few byproducts that can come up are often re-injected underground. Geothermal energy can also help recycle wastewater. In California, wastewater from the city of Santa Rosa is injected into the ground to generate more geothermal energy. Some plants do produce solid waste, but that solid waste may contain minerals that we can remove and sell, which lowers the cost of this energy source. The U.S. Geological Survey estimates that untapped geothermal resources in the United States, if developed, could supply the equivalent of 10% of today's energy needs and cut our dependence on fossil fuels. In fact, electricity generated by geothermal energy already provides about 60% of the power along the Northern California coast, from the Golden Gate Bridge to the Oregon state line. Geothermal energy, helping to push America toward energy independence and a clean, renewable way to meet our growing energy demands.
Today's video is just going to be a quick one to cover how geothermal power works and its pros and cons. Geothermal energy is thermal energy generated and stored in the Earth's crust. This heat energy originated from the initial formation of our planet, and from the ongoing radioactive decay of materials like uranium, deep inside the Earth. In fact, it's the same type of energy that heats hot springs across the world. We can use geothermal energy either directly for heat or to generate electricity. Heating is the cheaper of the two, and involves pumping water down into the ground, allowing it to warm up, and then pumping it back up to the surface to heat our homes. In contrast, in order to generate electricity, we instead leave the water underground until it heats up so much that it's converted to steam. As this gaseous steam rises, the gas turns turbines, which drive the generators to produce electricity. Unfortunately, we can only use this source in certain areas, such as volcanic regions where hot rocks lie near the surface, and the power plants required can be quite expensive to build. Where it is available though, geothermal energy can be a great source of power, as installing the plant only damages the environment very slightly, and while running it doesn't produce any pollutants like carbon dioxide. It's also a renewable resource and is reliable over long periods. Anyway,
the sun. Its vital rays provide the light and heat that living things on Earth need to survive. And the sun is also the world's most abundant source of energy. Energy is what gives us the ability to do work, and it allows people and things to change and move. Energy is everywhere and takes many forms. The heat and light that comes from the sun can be harnessed and turned into other forms of energy that we can use. When we talk about things related to the sun, we use the word solar. That's because our sun, like other stars, has a name. That name is Sol, and the word solar comes from that name. Solar energy is constantly flowing and won't run out for billions of years. Any source of energy that can't be used up is called renewable energy. Let's look at some of the ways this wonderful source of renewable energy can be used to better our planet and our everyday lives. When solar energy hits objects on Earth, it turns into heat, and this heat can be used to keep us warm and comfortable where we live and play. Ancient cliff dwellers in Arizona took advantage of this almost 1,000 years ago. By positioning their homes so that the winter's sun would shine directly inside, they used this natural resource to make their dwellings more comfortable. Today, people design homes and offices in ways that take advantage of the sun's warmth in winter or shield us from its heat in summer. This not only makes people more comfortable, but also cuts down on the costs of heating and cooling. People have also created ways to use solar energy to generate electricity. Panels built with light-sensitive elements and positioned to capture as much sunlight as possible are able to turn solar energy into electrical energy. Small solar panels can power street lamps. Larger panels can power homes, schools, and office buildings. Solar panels that are spread out over large areas are called solar farms, and they can provide enough electricity to power whole cities. Since using the sun to generate electricity doesn't burn fossil fuels like gas or oil, which can cause pollution and release large amounts of carbon dioxide into the atmosphere, solar energy is a clean source of energy. And it's a source that more and more people are using. It is estimated that 70,000 new solar panels are installed every hour. In a single day, enough solar energy hits our planet's surface to provide for all of humanity's energy needs for 25 years. With solar energy, the energy is there. All we have to do is capture it.
Hydropower. Hydropower, or hydroelectricity, refers to the conversion of energy from flowing water into electricity. It is considered a renewable energy source because the water cycle is constantly renewed by the sun. One of the first uses of hydroenergy was for mechanical milling, such as grinding grains. But today, modern hydro plants produce electricity using turbines and generators. The mechanical energy created by moving water spins rotors on a turbine. This turbine is connected to an electromagnetic generator which produces electricity when the turbine spins. There are two main types of hydroelectricity production: dams and run-of-river. Hydro dams utilize the potential energy from dammed water to produce electricity. A dam is a large barrier constructed to raise the level of water and control its flow. The elevation created by the dam creates gravitational force for turning the turbine when water is released. Some dams also contain an additional reservoir at their base where water is stored to be pumped to the higher reservoir for release when electricity is in demand. This is referred to as pumped storage hydro. The second form of hydroelectricity production is run-of-river hydro. Run-of-river still uses turbines and generators, but relies on natural water flow rates of rivers, diverting just a portion of the water through turbines. Because run-of-river hydro is subject to natural water variability, it is more intermittent than dammed hydro. There are various sizes of hydro plants that produce electricity. Large hydro, greater than 30 megawatts, small hydro, 100 kilowatts to 30 megawatts, and micro hydro, less than 100 kilowatts. The Hoover Dam in the United States is a whopping 2,074 megawatts, which is enough to serve 1.3 million people. Of all renewable energy sources, hydropower holds the largest share of worldwide electricity production. Hydropower has several benefits. It is a cost-competitive form of electricity, even though the initial building cost can be high. It is quite reliable compared to other renewable options and pairs well with other sources as it can be used as baseload power. In some cases, dammed reservoirs can also help with flood control and be a reliable water supply for communities. There are also some concerns with hydropower, especially when it comes to large dams. Damming a river has a major impact on the local environment, changing wildlife habitats, blocking fish passage, and often forcing people in riverside communities to move out of their homes. In addition, Dam failures can be catastrophic, claiming the lives of those living downstream. Hydro plants are also not completely free of greenhouse gas emissions. As with most forms of energy, carbon dioxide emissions happen during construction, particularly due to the large quantities of cement used, and plant matter in the flooded areas makes methane, another greenhouse gas, as it decays underwater. That's hydropower.
Math and science. In this video, we will learn about the water cycle. The water we use today has been around for a long, long time. That is because water can recycle itself in the water cycle, which is also called the hydrologic cycle. Let's start this cycle with the evaporation of water from the surface of the ocean. As this moist air is lifted, it cools and water vapor condenses. It may form clouds. In fact, clouds are made up of tiny water droplets and ice crystals that are so small they can float in the air. This moisture in the atmosphere may be transported around the globe until it returns to the surface as precipitation. Precipitation may take the form of rain, snow, sleet, or hail. Now, once this water reaches the ground, one or two processes may occur. Some of the water may evaporate back into the atmosphere, or the water may penetrate the surface and become groundwater. The groundwater may take several different paths. The groundwater may seep its way into the oceans, river, or streams. Or it may go into an aquifer, which is a body of saturated rock through which water can easily move. Or it may be released back into the atmosphere through transpiration. Transpiration occurs when leaves from trees and other vegetation give off water vapor through pores in their leaves. Some water on the Earth's surface is not absorbed by plants or become groundwater, and it becomes surface runoff. This runoff may empty into lakes, rivers, and streams, and then is carried back to the ocean.
They seem about as